Okay, guys, this next one is rotations. This one's kind of weird. Um, we've only been learning this one for a couple years, but I've kind of come up with a trick that makes it, I don't even know if I'd call it a trick, but a strategy that makes it a little bit easier to figure these things out. Um, what you have to be prepared to do is have a picture on a graph like this one here, be able to rotate it and give the new coordinates, or be able to match it to a picture. Matching it to the picture is not a big deal. The first thing we need to understand, with these rotations is there's only two ways to go. It's either clockwise or counterclockwise. Clockwise just means that it goes like a clock goes. Okay. Counterclockwise would be going the opposite way a clock goes. The other thing that you need to know is you need to know your quadrants. You need to know that the quadrant that you start in like kindergarten and first grade, the L is what I call it. All right, that's quadrant one. And from there, it does go counterclockwise with your quadrants. It goes 1, 2, 3, 4. So again, we need to know clockwise, counterclockwise. Clockwise is the way a clock goes. Counterclockwise is the opposite way. We need to know our quadrants, which is 1, 2, 3, 4. You start with the L, the one that's in the upper right-hand corner, and you go counterclockwise from there. And then you need to know what the signs for the coordinates would be. And when I say coordinates, I mean for the X and the Y. So follow me on this for a sec. For quadrant one, it's the X's are positives and the Y are positive. And the reason why is because we go to the right. Right is positive for X, and we go up. Up is positive for Y. Quadrant two is negative positive because we're going back. We're going left. That's negative for the X. And we're going up. That's positive for the Y. Three is going to be the opposite of one. If one's positive, positive, three is negative, negative, because instead of going right and up, we're going left and down or back and down. And then quadrant four is obviously the opposite of two, which if two is negative, positive, then four is going to be positive, negative. Again, the X's are positive because we're going to the right, and the Y's are negative because we're going down. So you're saying, okay, well, how's that going to help me out? Well, what we need to do is, and you really only, as long as the entire shape is in the same quadrant, you only really need to do this for one coordinate. So what I'm going to do is I'm going to select the A coordinate here. A is, and I make a T-chart. A is, this is 1, 2, 3, 1, 2. So the coordinate is positive 3, positive 2. So what I'll do is I'll say every time there's a rotation, the coordinates flip. It's kind of weird. Just take my word for it. That's what happens. So if we're going to do a 90-degree rotation, we're only going one time. And I'll show you what I'm talking about. If we go to quadrant 4, this is a 90-degree rotation. If we go to quadrant 3, that's a 180 degree rotation. If we do 270, it's 90, 180, 270. That would take us all the way back around to quadrant 2 here. And so they would ultimately flip 3 times. So to do a 90-degree rotation, they're just going to flip once. If we went 180, they would flip back. If we went 270, they would flip again. And that's what I'm talking about. Now, the only one that we need, I'm going to highlight, we're only going 90 degrees. So it only flips one time. And so the next thing you need to know is what quadrant are we going to be in? Well, it says go clockwise, so clock goes like this. So that means we're going to take this shape and we're going to move it down to this quadrant, which is quadrant 4. In quadrant 4, we're going to the right, that's positive, and we're going down, so our Y's are negative. So once again, 90-degree rotation, they flip one time. That's going to put them in quadrant 4. I'll always circle the quadrant. That didn't go good. I'll always circle the quadrant, just telling me what quadrant they're in. And I know what my signs for my X and Y should be in quadrant 4. It should be, like we had up here, it should be positive, negative. So that means that it should be positive, negative. So that means that I took A, which was 3, 2, and I made it A prime. By rotating it 90 degrees clockwise, it became 2, negative 3. So your next question would be, well, do I have to go through this T-chart for the B and the C? No, you do not. If you know that what you're doing in a 90-degree rotation is flipping the coordinate and going positive, negative, you can do that to all of them. So for example, B is, what is that? 1, 2, 3, 1, 3, 1. So B prime will flip, and it goes positive, negative. C is 1, 1. That's going to make that pretty easy. They're going to flip, but they're still going to look like 1, 1, but it's going to go positive, negative. And I will go ahead and graph that. Let me do it with a different colored pen. So 2, negative 3 is right there. 1, negative 1 is right there. And which one am I missing here? 1, negative 3 is right there. So my new triangle has been rotated like that. And so A rotated around to here to make A prime. That's the 2, negative 3. B prime rotated to right here, or B rotated to here to make B prime is the way I should say it. And C rotated from here to here to make C prime. And this is my new transformation. So again, how will they ask the question? They'll say, okay, rotate triangle ABC 90 degrees clockwise and give the new coordinates for A or for B or for C. But they usually just ask for one coordinate. The second thing they could do is they could give you this original picture, and then each answer choice be a picture of another triangle, and it needs to be the right rotation. So whatever picture looked like that would be the right choice, right answer choice in this case. The last thing they could do is they could ask for the rule, and if they ask for the rule, that's where it gets really tricky with the rotation, because sometimes it kind of looks like a rotation. I mean, it looks like a reflection, I'm sorry. So in this case, what did we do? We took all of our coordinates here, we flipped them, and the y went to its opposite. In this case, it was negative. So if this is our original x and y, what we did was we flipped it to yx, and then all the x's went to their opposite, and we show that by putting the negative there. So this is not one you're going to be able to watch a video on one time. This is one you're definitely going to have to do some practice on. So definitely look at the notes that I give you. Definitely do the homework assignments as practice, and then definitely go back and look at those homework assignments and make sure that you know how you got the answers you got. Rotations is going to be a tough one, although once the kids have gotten practice with it, in my experience, it hasn't been that big of a deal. And the best thing about it is it really makes you strengthen your understanding of the coordinate plane, which is going to play a big role when you go into algebra next year. So please take rotation serious, because it's a big one. And that's rotation.